right, welcome everybody. We're going to talk today a little bit about data profiling. Who has done any sort of data profiling or has heard the word at all? Wow, that's great, because usually I do this presentation and everyone's like, I have no idea what data profiling is. I have no idea. So we'll talk about a little bit about data profiling, kind of what it is, and the techniques that we have to find some of this data and then clean. So I'm not going to tell you how to clean it, because that's usually either I delete it or I change it or I do something with it. That seems pretty straightforward. But how do I know I have a problem? That is what we're going to talk about today. My name is Richie Rump. I actually no longer work for Joris LLC, but it's still there. I still kind of do stuff on the side occasionally. You can find me at Joris, Joriss, on Twitter, which I tweet a ton, so you're good with that. Hopefully y'all follow me. And you can find me on joris.net. This presentation is on joris.net. The slides are on there. The GitHub repos are out there. It's all there, so you should be good with that. All right. I've always felt when you go into conferences like this and you see someone up there and they start talking and you have no idea who they are, that always kind of got me. It's like, I would at least want to know if you know what you're talking about, right? So what makes you qualified to stand up here? So a little bit about me. I'm the user group leader for, it's not a user group, the community leader for .NET Miami. We are a user group-ish type organization in Miami where we focus on enterprise development, specifically on .NET. I'm also a Microsoft Certified Solution Developer and IT professional, primarily on the database side of the house. I'm also a friend of Redgate, and for a short period of time, for about 5 years, I was actually a project manager as well. So I'm a PMP, and I've got the Scrum Master certification, which was insanely easy. I think I lost brain cells taking that exam. So that's a little bit about me. Hopefully there's no questions about that, because I'm not going to answer any questions about that. SQLgenerator.net. So I'm going to talk a couple of tools about what I have been working on, some open source stuff. One of them is called SQLgenerator.net. I've kind of been beta playing this out a little bit. So the genesis of this is people have pivot tables, right, that we want to create. Well, every time I go to write a pivot table, I don't understand the syntax, right? I don't write this. Well, this kind of helps you write the pivot table syntax. You put your query in there, and then it will go off, and it will do ask you a bunch of questions, and at the end, you'll have a pivot statement, and then you can go ahead and run that. So eventually, I want to add merge and a couple other things to that, but this is just something I've been toying with kind of in the wee hours of the night. The other one that I've put out there is called statisticsparser.com. Anybody used statisticsparser.com? One. You the man. The one guy has used statisticsparser.com. So this is a really focused tool. If you're doing any sort of query tuning whatsoever, most likely you'll be using switches called statistics IO or statistics time. Well, if you use those kind of switches, it will tell you how much your page reads are and how long things take in your query. The problem is that it's all one string and it's not aggregated up and it looks really ugly. This tool, you plug in all of your output, it will make it pretty for you and do some aggregations so you could actually understand why I have 1 million page reads against one table. Okay, that's statisticsparser.com. The other project that I've been working on, yeah, I don't sleep, and this is called Away from the Keyboard. Has anyone heard of Away from the Keyboard? Yes, thank you. Thank you for listening. We appreciate that. This is a podcast that we've started, and the idea is that as technologists, we're more than one type of people. We're more than just technology. We're human beings. And we talk to technologists like Julie Lehrman here about kind of how she started, how she became an expert, what her hobbies are, and pretty much anything kind of not about technology. So we want to get to know the person as they are. And that's kind of the concept Away from the Keyboard. We're 15 episodes in, and we'd really love your feedback and have you check it out. So that's awayfromthekeyboard.com. And my co-host is sitting right back there on the camera. So say hi, Cecil. Hi. All right, so let's talk a little bit about data profiling. But first, let's talk about this guy. Anyone recognize this guy? Shh, we can't say that. I don't have license to say that here. It's OK. Shh. He's an explorer. But nowadays, business runs on data. And decisions are made at every level based upon data. But when the data is bad, our decisions tend to be bad too. Perfectly clean data is a lot like lost treasure. It's what everyone wants, but few people really get it. And it's really, really, really hard to get there. Right? We agree on that? All right. So when you start cleaning up a data set, as I'm sure all of us have in here, everywhere we go, there seems to be some sort of problem. A type is missing, a string is too long, there's a date that's misformatted, and then sometimes we get kind of boulders chasing after us. And in fact, good data is really hard to do. And then when you finally do get that data set cleaned up, your boss steals the credit, gives you another data set to clean, and you have to go do it all over again, right? So, I laugh, so I guess that kind of sounds familiar. So what we really need are some tools to kind of help us identify and clean data fairly quickly. And although a gun and a whip work out really well, we need something that's just a little bit better, a little more targeted for our data sets. So using these data profiling techniques is much better. Cool? All right. So what is data quality? So this is getting from Wikipedia. We'll talk a little about data quality before we talk about data profiling. So data quality is the degree of excellence exhibited by the data in relation to the portrayal of the actual scenario. The state of completeness, validity, consistency, timeliness, and accuracy makes data appropriate for specific use. You really wanted me to read the rest of that? Because I could do that. Seriously, you wanted me to go talk about data quality? No, it's a little dull, it's a little boring, and frankly, we're at a developer conference, right? We're the guys that actually get stuff done. We're not the guys that sit in our corner office and dream about all these crazy schemes that probably won't work, right? This is not going to be a strategy conversation, right? This is going to be a discussion about how to really get things done. It's going to be a tactical presentation on how I could go into the data and what techniques I could use to actually see if there's a problem with our data. All right, everyone okay with that? Are you sure you don't want more boring enterprise-y buzzwords? Because we could do it. I mean, right there. You sure you're not a manager? See, pegged her out. Yeah, see, I used to be one. I could see him. I could see him. Okay, so what we're going to talk about is really investigating what data profiling is. We're going to look at the techniques, and I'm going to walk you through some tools. Okay, we're going to start off at kind of a very detailed level, things we could do in SQL right now to kind of get the concept together. But then we're going to talk about some of these free toolings so that we understand how it works in SQL. How do these toolings kind of help us? Because these words that they use in these tools are really weird and they're odd. So we're going to give you some baseline, and then we're going to add some stuff on top of that. Is everybody cool with that? All right, so they're cool with it. Y'all ain't cool. Y'all just like, nah, man, go beaches out there, man. I'm going to do that. All right, so everyone good with that? All right, so if I don't see anybody head nod, then Cecil and I are going to go record a podcast. That's probably what's going to end up happening. But I will read this. So I found this, and this turned out to be a nice definition of data profiling. So data profiling is a process whereby one examines the data available in an existing database or flat file and collects statistics and information about that data. Okay? So what we're trying to do is we're trying to get data about the data so that we can make an intelligent decisions about the quality of that data. Right? In a nutshell, that's what data profiling is. Cool? Good. So why do we need to use data profiling? Because one, we need to transform the data. Right? That data is in one format, and I need to move it to something else. I need to make sure that all the data is good. Right? I need to move the data. It's in one database, and I need to get it to some JSON file on our web server. If I need to find patterns in this data, how many have actually had to clean out zip codes? How many different patterns have we talked about there? So if we actually do a like string on some of those zip codes, are we actually going to pull up the right stuff? Phone number is even worse. So those are the type of things that that we will need data profiling on. If the data is unknown to you, if you walk into a new client, or if you walk into a new situation, or you get put on a new project, I need to know something about that data. Using data profiling techniques will help you understand how that data is, because an ERD may say one thing, but the data may say something else. Okay? I want to improve the data quality, right? I need to make sure that there's no errors and some oddness that goes into it, and wibbly wobbly data warehousing stuff, right? That's when we're going to use that. So here's some of the high-level data profiling techniques. So they're called column profiling, table analysis, cross-table analysis, and business rule analysis. We will not be talking about the cross-table analysis or the business rule analysis. Out of scope for this presentation. All the most fun things are talking about here anyway, in the column profiling and the table profiling. All right, we agreed on that. Sweet. So what goes into column analysis are these things. And when we talk about data profiling, most of the time we're talking about column analysis. We want to get the inferred data type. So if I have a flat file, I'm not going to have any data types associated with that. So I'm going to go and take a look at that, and I'm going to say, OK, was this a date column? Is this a field? Is this a numeric? I need to do all that and figure it out, right? Data profiling will help us do that. Data types, if there are data types there, are they the right data types? Or is everything a varchar? Which could have problems when I start doing queries and have where clauses, especially if it's, hey, if it's greater than 1. OK, what does that really mean? So these are so that is one of the things we need to take a look at. Min, mean, and maximum values. So now we're talking about getting dates and numerics, having some sort of aggregation so we could see the actual range of values here. So who's actually doing this right now in their data, doing min, max, and mean to see if they actually look good? Ooh, cool. Love you guys. Distinct values, so we could actually see what the values actually are, and frequency distribution. So anyone understand what frequency distribution is? Crickets. I love interactive, guys. You got to help me out. You got to work with me. Those are essentially counts. So every time I say frequency distribution, I want you to think counts. So distinct values and frequency distribution counts actually kind of go really hand in hand together. Right? So we want to know how frequently something occurs in our data set. And then pattern analysis. Right? We talked about zip codes and phone numbers. Well, what kind of patterns do we have in those zip codes and phone numbers? Right? What kind of oddities are we actually dealing with in the data? So table analysis, what we're going to do is we're going to identify the primary keys. We're going to identify candidate keys, verify the foreign keys if they exist, and if they don't exist, should they exist. The candidates for normalization and duplicate rows. So everyone has had problems with duplicate rows, right? I mean, we all have issues there. And a lot of times that happens because we don't have the valid alternate keys or these candidate keys that are locked in our databases. Right? So that's a big thing. I've actually gone into clients and said, y'all got dupes everywhere. You need to come up with some alternate keys because your primary key is an identity column, and you've got 4 or 5 different of the same values because you don't have your proper keying in there. And one client, we actually walked in and cleaned it all up. And it took about 3 weeks, but there's no dupes in the data anymore. So cross-table analysis, where we're looking for relationships between tables, and we're looking for duplicate data. So I'm going to buzz through this. And then business rule analysis, where we take our business rules that the business has, and then we're going to apply that to the data set. Okay? A lot of times when we walk in as developers and data people, we don't know what those are. So we have to go and find that out. So I can't talk about your business rules because I don't know your business rules. So if you want to hire me, I mean, we could go off and, and talk about your business rules all day long. But that's why we're not talking about business rule analysis in this presentation. All right, so let's go ahead and get into some column analysis. So when we get into a data, and we get a data set, what's the first thing you guys do? What's that? I can't hear you. Yeah, look at the schema, right? What else? What other things do we do? That's it? We just look at the schema and we go home, pop open a brew one, cold one. Let's go, middle of time. No? Maybe check the data types? It's all here, guys. I mean, this is not a trick question here, you know? First thing that I do is I like to go in, like you said, I want to take a look at the schema. What columns are we talking about? Take a look at the actual data itself. So let's, enough slides. Let's go ahead and start working on this as it is. So there we go. So I'm going to run a ton of queries here. And you don't have to worry about following along with the queries. Just understand that we'll be running a ton of them, and the actual, and then the actual queries are out there. I'm running up against the Stack Overflow database. Okay, everyone understands what Stack Overflow is? How many have 60 gigs of data in their databases right now? 3, 4, 5. So 5 out of what, 30 people that are sitting here? Yeah, Stack Overflow is 60 gigs. So we're talking about a fairly large amount of information. And this is actually all available out there. They make dumps on a quarterly basis. you could actually take this data right now, shove it into your local machine, and then actually run all the Stack Overflow databases up against, all the queries up against Stack Overflow. Very cool thing, makes great demo data. But one of the things that I like to do is I like to run DMVs up against when I like to run queries up against the DMVs so I can see what's going on inside there. And the main one that I look at is this guy right here, rows. For the post table, we have 18 million rows. Okay, we could do the same thing for this users table, and we'll get 2.7 million rows. I could do a select star account, a select count on that table and figure that out. It does take a little bit longer to run. It is a little bit more accurate, but I'm not looking for accuracy here. I'm just wanting to see, well, what's the size of my data? How many rows are we actually talking about here? Then I could run up against another DMV and take a look at the columns. I could actually go into our Object Explorer here and go click, 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 but sometimes I hate that. If I have 300 tables, I'm click, 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 oh, wrong table, click, 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 click. And as a developer, I just want to type things out. That's just kind of my workflow. So we could see here and we could say, oh, we have a lot of interesting things. Body is end text. Maybe I shouldn't be using end text here. Maybe I should be using env_var max. So these are the type of things that we should be looking at when we first encounter a data set. The next thing I really like to do is I like to take a look at the data. And I want you to help me take a look at this data. Okay, can you do that? I know it's after lunch. Work with me. So when we take a look at this data, what are some of the things that you're noticing here? Something here maybe? Yeah. Yeah, what if I went ahead and pumped that out to a web service and it's not doing HTML content? Would that be a problem for us? Yeah. Yeah, it probably will. If I'm serving it out to a mobile platform that's not having HTML, could be an issue. All right, so that's one thing that we're looking for. We're looking for these things, these little issues that could give us problems inside of the data. Anything else here that you kind of noticed? Anything? Is looking at data boring? Why are you in a data presentation? So one of the other things, what about this guy right here? Or about this one right here? What would that tell you? What column is that? Parent ID. What would parent ID tell you? Yeah, I may have some sort of hierarchy involved in these posts. Right? So that table has some sort of hierarchy involved. What that is, I don't know. But there's probably some sort of hierarchy involved, or someone did a really bad job of naming the schema. Right? It wouldn't be the first time I've seen it. Anything else? Maybe here? Do you think this is normalized or denormalized?
It's denormalized.
Yep, it's denormalized. Right? So if I want to go and find all the JavaScript what tag equals JavaScript, am I going to find them all? No, I have to use some sort of crazy light query to try to figure all that stuff out, right? So these are the things that we want to look at when we're taking a first crack at that data. We're looking for things that will tip us off so that we can start asking questions. Because these data profiling techniques, there's not one thing, well, you do this, and then you do this, and then you do this. It's more of, I do this, and I've got these questions. Well, I'm going to pull this technique out of the bag, and I'm going to answer that question with this technique, and then so on and so on. I wish it was more of a pattern, but I haven't found it yet. It's more of, hey, I want to use this and this because I have a question in the data, because I have some problem with this. Okay, so we'll do that. So I'm going to go ahead and move on. And the next thing we want to take a look at is, remember I said, is how I scroll and how I have a problem scrolling. I have a scrolling problem. And that's min, max, and median. So this is that we're going up against one column, and that's the age. And we're going to run min, max, median, and mean. So that's the average. And we're trying to figure out, OK, well, what is the range for a typical Stack Overflow user? So what does this tell us? I have a min age of 13.
You're not allowed to be younger than 13. There's some constraint.
Yeah, so what is that constraint?
They're probably lying. I mean,
Oh yeah, or people are lying. Do you think we could have Stack Overflow users that are younger on our website than 13? Yeah. So the real question is that why am I 13? Now, we probably would have to ask a subject matter expert or a manager or something that's not in the database that's telling us why we have gotten younger than 13. But that's a valid question. Why don't I have users younger than 13 in the data, right? What about max, 94? Do you think that we could have a 94-year-old user in Stack Overflow? Maybe, yeah! Wouldn't that be so cool? You're 94 years old and you're still coding. How awesome would that be? Right? That you could actually use your eyes and read Stack Overflow. How amazing is that? So yeah, so that would be really cool, but that's not out of the range. If it was 130, do you think we would have some sort of problem here? Yeah, that would point to a data quality issue. We have a mean age of 30. Average age of 30. What does that tell us about our website? What's that? Tends to be younger. That's kind of odd, don't you think? So what do you think what kind of users are on Stack Overflow? What's that?
I said old people.
Yeah, oh yeah, old people. Me, that's what you're trying to say. You're the only one on Stack Overflow. I am Stack Overflow user 629. So maybe, maybe you're right. But it's people answering and asking computer programming related questions, right? So what can we say about the average age of 30 and people asking technical questions? Is there a correlation that we could talk about that? Is that maybe programming is a young person's game?
Or you could say that after a certain age, you find a specialization and you're not asking as many questions in an open forum.
That's potential as well, right? Is that maybe we're not even, maybe we're so far ahead, we're above Stack Overflow. That's right. I like to think that of myself, but I know that's not true. Yeah, we could have our own niches, right? We all create our own websites to answer our own questions, right? All of us over 30, we all have our own blogs. That's what we did. But the other interesting thing is that we look at our medians. And so our medians essentially is our middle. In this case, it's our 50%. So we have a lot more folks, users, in Stack Overflow that are 28 and under than are over. So that will tell us if there's any deviation or skew of our data set, right? So which means that we have a lot more younger folks than we have older. So that's what that median is telling us. So is this interesting data? Do we try to figure out what's going on inside of it?
What about the gender?
So I don't think they provide gender in the dump. That would be great information to have, though, right? So how many male versus female? It'd be awesome if it was like 51% female versus male, because then it's like, oh, well maybe they are answering all these questions. See, that would be another interesting. What's the percentage of your age versus if you're asking questions or answering questions, all right? So that would be something else, and we could cross-reference all that. And see, now we're not really getting into data profiling at that point, but we could go all day with this. I love this kind of stuff. This is really awesome. So the next thing that we could get into is nulls, and I'm going to go back into the slide deck here for the nulls because a lot of our developer friends, me included, a few years ago, didn't really get a concept of nulls, right? So let's give a little review on nulls. Who likes nulls? Who's a big fan of nulls? Nulls, good? Oh, interesting. Okay, so I know a lot of DBAs really hate it, and I don't know, I'm not quite sure why. I've had many conversations, but null is an unknown value. So that's all null means. It's unknown. We don't know what it is. So does null equal null? No. Why is that? Because we don't know, right? I can't have an unknown equal to unknown, right? There's no way. That's why when we do a join on nulls, they're not going to match up. If I have a value equal to unknown, it's not going to match up. If I have an unknown versus unknown, it's not going to match up. That's why when we do inner joins, it's not going to come in there, right? So does that make sense now with nulls? Now we got a baseline of nulls. But it's a problem. It's a problem when we get our data sets and we're taking a look at it. Nulls are a problem. So we have to understand what they are and how we're going to deal with it. So the first thing we need to look at is the column actually in fact nullable? So I have a bunch of nulls in there that I'm trying to move into another data set, another column, and it's not nullable. I have to figure out what value I need to put in there. So how many nulls am I dealing with? So I need to understand that. Am I dealing with 87% nulls? Do I have 100 nulls out of 100 rows? Do I have 1,000,000 rows and 100 nulls? How big is my problem? And we talked about what the percentage of nulls are. So let's get back into some code and take a peek. at nulls. Nulls. Why did it have to be nulls? See, I even wrote that in a comment. Remind me to say it. All right, so what we're going to do is we're going to get the number of nulls, the number of rows, and the ratios for a closed date in the Stack Overflow database. And it should give us a little idea of if we have a problem or if we don't. So how many rows are in this table again? What's that?
I think it's like 2.8, I think.
Yeah, so 2.8 was users, where this is the post, so this was, what, 18? 18? On my little machine. So it should take a few seconds, and then we'll take a peek at it. Awkward silence. I'm OK with awkward silence. I live with awkward silence.
Were you casting the count from post test?
What's that?
Were you casting the count from post test?
Decimal, yeah. All right, I may have to just kill this thing and kind of move on. See, this is what, there we go. And nothing was in cache. And I run it again, I'll bet you it'll run real fast. So here we have 17.8 million nulls. We have 18 million rows and a ratio of 98%. All right, I have 98% nulls in a close date. What does that tell us? A lot of open. Now, this is Stack Overflow. It's a fairly popular site. If I had questions that were open, 98%, do you think people would actually be looking at it all the time and it'd be the first thing in Google that we see? And so what do you think is going on here?
Do replies ever get a close date?
Right. So what else is in the table in posts? So the fact of the matter is replies are in there, answers are in there, comments are in there. Kind of anything that you would go and put into Stack Overflow goes in the post table. So we're looking at a very low percentage of actual questions that are answered actually in the post table. The rest are all the other conversation that's going on around those questions. Right? So these are the type of things that we can answer with just a few queries. So I'm going to, do I want to skip this next one? No, I don't. I should, but I'm not. So there we go. Here, this is for the accepted answer ID. So this is accepted answer ID on Stack Overflow. Now, how many nulls I got there? 0. How many rows? 18 million. So does that really make sense? I have a close date that has 98% null, and then I have 0 on accepted date. So what is actually going on here is that they actually have an ID of 0 that says, hey, it's not answered. So they don't have nulls. But the actual column is nullable. So the change that we could actually make here to make our data better is to change that to not null. And now if there's anything that comes in null, we won't have an unknown value. We would know what it is. It would throw an error, and then we could handle it there. Right? So let's take a look at frequency distribution. And I guess we'll go right back to the slides real quick. And this is when we look at the individual values of a column. And so we see how often they go on. When I said frequency distribution, remember what I said think of? Counts, right? So essentially we're doing counts on the actual data themselves. So let's take a quick peek at what they would look like in a query. And I'm just going to do this one right here for post type ID. And don't hit F4. Don't hit F4. So this is for a post type ID in post. And in here I have 6.4 million for post type ID 1, 11.5 million for post type ID 2. And I have a whole bunch of other stuff that's here that's not even close. Right? 167 million, 25.83 million. So there's a lot of stuff going on. The blind bulk of the share of post type ID is already taken up with this 1 or 2. Right? So what would you do with this information? What could you pull from this? I don't have any post types. I don't know what they are because they didn't come across. What can I actually pull from this type of data?
Well, you probably can figure out that number 2 is the replies.
Yeah.
Comments.
Yeah, and then maybe 1 is the questions.
Might be the answers, because it's more than, usually questions are more answers.
Yeah, and that probably is the answers. Yep. The other thing that I don't know why this is, because I didn't take a good look into it, but why do I have the same exact number for 4 and 5? It can't be a coincidence. There's something going on there. Those things are related somehow. Don't know how. But it's another question that I could go and write down and I could go and investigate later. Now, it's something I probably wouldn't even guess if I was just thumbing through all 18 million of these rows. But now that I've aggregated everything up and I've taken a look at it like this, oh, there's something going on here. Why is this work like this? All right. Cool? Interesting? Not so interesting? We'll run this real quick. Ooh. If it comes back quickly. So what we're doing here is that we're taking a look at all the tags and all the counts that are in the system. And lo and behold, we have 11.5 million that have null. They don't have any tags whatsoever. But I have a whole bunch of other stuff here. So I've got Android, and I've got PHP and JavaScript and jQuery. So this is where the problem of the denormalization issue of this tags really comes to light. So if I wanted to do where equals JavaScript, I'm only going to get the one tag. I'm not going to get it where it's multiple tags that are in there, right? So, but here, this would be really interesting because here we could say, well, we could kind of deduce what questions are people asking about these different technologies. And if I was able to get this in a normalized fashion, I could actually ask them really interesting questions and write interesting queries about what is the actual usage on the Stack Overflow site. And I know they take this data and they do all sorts of great aggregations and statistical analysis on this stuff. But it's the same thing in our own organizations and our own data sets. There's data here that people aren't even looking at or that aren't even aware of because they don't have the opportunity to actually do anything with it because we've got some weird formatting going on. Right? Understood? Any questions? Yep.
Would you possibly imply that using non-null is preferable except for daytime calls from a data profiling perspective and analysis?
So from a data profiling perspective, we don't care, right? We just need to understand what it is. That's what we're trying to figure out. From data profiling, we're just trying to figure out what it is and is it actually valid or not. But from a data schema perspective, from a data architecture, I want not know wherever I can put it. Because then that erases a whole bunch of stuff. Now, I'm not going to go crazy with that. But if something can be nullable, I'm going to make it nullable.
Yeah, could you scroll down a little bit in that list?
Sure.
I suspect that there's probably be a lot of queries that have multiple.
Yeah, and they'll get more popular as we go down. Yeah, see, look, JavaScript, jQuery, HTML, C#.NET, SQL Server, Ruby on Rails. So yeah, they get more frequently as they go down. But the single tags are the most popular together, right? All right, so I'm going to talk quickly about pattern analysis. And pattern analysis is interesting. What we are actually trying to do is we're trying to say, OK, what patterns are in my data? Now, it's really hard to do that in SQL. We can't really do true pattern analysis in SQL Server because it just doesn't have the tools to do that. But what we can do is that we can try to figure out some of these patterns in SQL. And this one is, hey, what makes a website URL valid? And in this case, I could say, hey, is it http://? I can sit there and run it. And immediately I say, this isn't good. I can't validate a URL because http:// null or none is not a good URL, right? That's poor. That's a poor URL. I could try to do some other things with it using like, where hey, maybe if those URLs just don't have an HTTP in front of it, and it turns out that there's no URLs that don't have an HTTP in front of it. So it seems like there's a system thing that you put the URL in there and it's actually putting HTTP in front of it if it's there or if it's not there. And we may have another data quality problem here because I have empty string right here as opposed to a null. So that could be another issue if we're searching for things. So if I'm expecting, hey, if it's not there, have a null, not empty string, that could be a problem for our users who are querying data, right? You got that? Maybe so, maybe not. There is one thing that we could actually do, and I will show you. We could use .NET and to take a look at some of these guys, right? So we can take a look at, see someone looked over there. The DBAs hate this stuff. You're just like, no, don't put .NET on my SQL Server. So you may not be able to run this in production, but I'm pretty sure if you have a dev machine that you control, you could do this. What this function is doing, and I didn't find this on my own. I got this from 2 different sources up here, and again, the code's on GitHub. But all we're doing is that we're creating a function, and we're going to shove this into SQL CLR. And we're going to take a pattern, the input, and then any options that we may have, and I'll show you the options in a second. And we're going to say, hey, does it match? And if it matches, we'll say yes, and if it doesn't match, we'll say no. And that's all we're going to do. Then what we could do is that we can go back into SQL Server, and then we could do the following. Is I could enable the CLR if it's not enabled already. I could then create an assembly and point to where it is on the drive. In this case, it's data CLR. That's just where I put it. And then I could create this function. And it gives me a red squiggly because the function's already there. And then I point to the external name, which is regular expressions, functions, regular expressions, functions, regex is match. And then we could actually run this guy. And so remember I said options? These are the actually options that are in the MSDN for regex. And if I want to do ignore case and multi-line, I wouldn't put 1 and 2. I would just say 3, because 1 plus 2 is 3. And then that's how I would do ignore case and multi-line in my regular expressions. So it gives us a lot of flexibility to kind of do different things. And now if I wanted to do a regex to find valid URLs, I'm just throwing in my regex here. See, look at that. I didn't do this myself. Again, another internet thing. I didn't want to waste my time trying to figure out how to clean URLs using regex. So if we run this, it's going to give us kind of all these valid URLs here. And there we go. Do all these kind of look good to you? A lot better than the ones we saw before? None.com. There you go. It's valid. And so here we could say, here's our good ones. And then we could actually say, OK, here are the ones that are invalid. We could pull them out, and then we could decide what to do with them. Do I want to delete them? Do I want to archive them? Is there some sort of decision process that we want to do with these bad URLs? But this is just an example of how we could take data profiling to the next step to actually validate the data that's inside, as opposed to just, oh, are we within a range? Is this cool? Is this news to anybody, that we could do stuff like this? Yeah? It's pretty cool, though, right? That we could actually leverage .NET and really make the query engine run a lot faster. And this was up against, this was in the users table. So it's 2 million rows, and we got that in a few seconds. So the performance isn't bad. It's not great, but I mean, it's really not bad at all. So I'm going to keep moving forward with this. And then we go into table analysis. And I'm kind of moving a little fast because I want to start giving you demos of some of the tooling stuff. So is everyone OK with that? We start getting some tooling demos? Yes, let's start doing it. So I'm going to go pretty quickly over the table analysis stuff. So we did pattern analysis. So table analysis, we want to identify the candidate keys. This is really important if I'm getting a lot of duplicate data inside of my data set or my table or something like that. If I have candidate keys in there and I apply them as unique constraints or alternate keys, guess what happens? We don't get that duplicate data anymore. So we could actually use finding the candidate keys to do that. Now, I'm not going to get into the query stuff, so we could actually start working on some tooling stuff. But we'll get forward. We could actually write queries to go and find all the duplicates in the data and test to see if we would have a valid candidate key. And I'll show you a tool that actually will help us with that. Nextly, we want to verify foreign keys. I walked into a system last week, and I had 300 tables, 60 relationships, and a whole bunch of assumed relationships. So what did I do? I took an ERD, an old ERD, that actually had all the relationships, and then I put that up against what actually was there. Every relationship that was missing, and I tried 20 of them, had bad data inside of it. Had data inside of there that did not relate to the parent table. That's a problem, right? Now I've got something that means something that doesn't mean in the related table. I don't know what that 0 meant or that null meant or that -1. It's not in there. So either I put it in the parent table or I figure out something else to do with that. So that's what we mean by verify the foreign keys. If we actually have the relationships there, then we don't have a problem because it's actually enforcing all that. The hunt for normalization. So we saw that with the tags. We want to make sure that we are at the right normalization levels. A lot of developers, because they have some sort of problems with performance, they tend to denormalize and try to make things a little bit faster. Well, frankly, that's why we have data warehouse to do this kind of stuff. But sometimes when we actually need to write to now 3 tables as opposed to just 1, we could run into some problems, especially if inserts are taking too long and things like that. So we want to take a look at that and see if we pull this out, we'll be able to query better and will we be able to have our inserts just act as a little bit more performant. All right, so that's one thing we do in table when we take a look at the table as a whole. And in duplicate rows, we've actually talked about that. So there's that. So let's get into SSIS. So did anyone know that we could actually use SSIS for data profiling? All right, so a couple head nods, a couple shakes. Now, would it surprise you to say that we've had this task in there, the SSIS data profiling task, since 2008? Shocking? Maybe not. It's been in there a long time. And in fact, I didn't know this until about 6 months ago myself. So you're in good company. But it does some things that are kind of off, like it outputs the information in XML. That doesn't give me a good, warm, fuzzy feeling that I can read it. But it does come with a data profiler viewer. And that viewer is actually pretty darn snazzy. So we could take a look at this in SSIS. And just to show you I'm not fooling you, oh, I got to pull up this stupid new SSIS toolbox, which I'm not going to do it. Oh, denied. Adding toolbox items. Can you tell this is a fresh install? All right, good, that went away. So it's actually over there. It's called the data profiling task. If I double click on this, I get this task editor. The easiest way to use this thing is to use this open profile viewer. Or actually, no, not the viewer, the quick profile, right next to it. What we could do is we could add a connection, and then we could say the table we want, and I'll say posts. Maybe that's better. And then we could check all of these different type of profiling techniques. The column null ratio profile, the statistics profile, pardon me, the column value distribution profile, which we've seen, right? How many the actual values we have in there. The column length profile, which we haven't seen, which tells us how long something is in a string, which is interesting, I guess, if you're stuffing it into something smaller. But that's the only thing I could think of that why this would actually be useful. And I'll show you what it actually does. It's interesting, but not that interesting at the same time. The column profile, pattern profile is interesting because it actually can pull out, using regex, it can pull out common patterns inside of your data. Definitely going to show this to you in just a second. And then the candidate key profile, which will actually show us if there's any valid candidate keys and if there's any duplicate data for that candidate key set.
On that link profile, wouldn't that be a good place to show that if they use a Vericare Max, when they want to use a Vericare 5 or Verify?
So that won't actually show you. Let's walk through it, and maybe we'll answer that. But I don't think that will tell you, hey, it will tell you that the length, but it would be for each individual value. Yeah, so that's why it was, yeah, that would be nice, but it's kind of weird. And maybe if I could column length distribution profile. So this is what this is right here. And maybe if I zoom out, we'll see. I could see more. All right, so this is what this column length distribution profile does. And I have here for the display name, these are all the values that are inside of the lengths of all the values that are inside of the display name. It's interesting data, but I don't know if it's actionable, with the exception of if I have anything too long. The weird thing is that I have here in this number 11, it's the length 11 is kind of like the magic, it's like the perfect number of user display name on Stack Overflow. So we have 32, almost 32% of all usernames, display names in Stack Overflow are 11 characters. Can we do anything with that data? Is that something that I can make a decision on?
You could go down the bottom, you should pick the max length.
Yeah, it won't actually, because there's a threshold to it. Yeah, so it won't actually go through it. And they actually trim it too. So this is it. It's 36 is the max in here, and then that's done. But there's thresholds on this thing, so it won't report after a certain threshold. And you could actually tweak it when you're set all this stuff up. You could tweak it. Well, what's my threshold versus what's not? Interesting information, but I'm not sure we could do much with this guy. Candidate key profiles. Again, this is also interesting things. We didn't talk too much about the actual data inside of here, but for the users table, the account ID may be an interesting alternate key for us. So I have this account ID that's 0, 56 times, and then I have these two numbers repeated twice. If I'm able to clean this data up a little bit, the account ID may be a valid alternate key for us. And so if that is unique across the board, which it is over 2.7 million rows, this may be a good way to go, as opposed to throwing a create date and all these other combination of values together to come up with an alternate key. The column null ratio profile kind of does the exact same thing that we were doing before. Now, I hadn't shown this to you before, but I could double click on any one of these and it will actually show me the data down below. See, I've got all this. Remember we talked about the age, and then the age kind of told us about, well, maybe Stack Overflow and programming is a young person's game, sorry. And we came up with the kind of the conclusion of, yeah, that's it. With most younger people, they're the ones doing all the coding, and the older people, they're off on their own blogs, they're doing something else, right? Well, what if I told you that 87% of the age is null? Would you come up with a different conclusion then? No? Maybe that's the answer, right? So maybe if I'm older, I'm not going to put my birth date in there, right? But if I'm younger, I'm perfectly okay with that. So looking at these individual techniques together will give us better answers as well. Okay, does that make sense to you guys? So now I took a look at the nulls, I took a look at the min and maxes, I took a look at all that stuff. Now I put it together and I have more information to make maybe a better decision from what's going on inside the data and what's going on inside our site. Is that cool? What do you think about the tool so far? Interesting? Make things a little bit easier than writing queries? Yeah, I write queries because I'm an idiot. I love this stuff. All right, so column pattern profiles. This is what we were doing with the URLs and the regex and all that stuff. But this is actually a better way of doing it. So what this will do is, and I'm going to go down to the URLs because that's what we were working on. What this will do is that this will go and say, OK, well, what are my common patterns inside of the data? And there's a ton of tweaks that you can kind of play with this. There's a lot of things, little switches that you can play with and run against your data set to see, well, how can I get better patterns in this? But in this one, it's not bad right out the gate. So in this case, I've got 38% that has http:// word.word.word. And if I double click on this guy, come on. There you go. And that's exactly what I get. http:// www.something.something. Right? 38% of the data says that. And if I double click on this, it's going to be word.word, essentially stackoverflow.com. And then I could do the other 6% is something that has a / at the end of that. Right? And then 34% is everything else. Now, what if I threw this up against phone numbers? Right? Does everyone put the same pattern for phone numbers inside of our database? Yeah, phone numbers are usually a huge problem, and most of the times we get it because I'm getting it from this system and this system and this system, and they all wrote it down the different ways, and they dumped it into the same system. Right? Well, this way we could say, well, what are those patterns? Can I go and identify the columns of those patterns and then clean them? Right? How big is our problem? Are we talking about a problem that's, hey, 100 rows or 100,000 rows? So these are the type of things that this tool will kind of bubble up to you guys. Kind of a better way of doing pattern analysis than what kind of the stuff that we were doing? Maybe? Maybe a little bit? Maybe it's time for the next session? All right. A few more things. This is the column statistics profiles. Exact same thing that we were doing with the mean, and maximum. This actually threw in the standard deviation, which I appreciate because I love all statistical stuff. But it's the exact same thing that we had from the query, where the minimum was 13, the maximum was 94, and the mean is 30. Right? So it's giving us the exact same information so that we could do it. Now, I hate all the decimals at the end of that because there's nothing I can do about that. Right? 30 is good enough for me, 30.2 maybe, but anything after that is just ridiculous. But it's very interesting data that we could go about. The column value distribution profiles, again, gives us just kind of the count of all this stuff. And if we take a look at the ages, and here we go, we can see all the distribution of all that. And you see here, now this bubbles it up even more. I take a look at my percentages, and the percentages are really, really low because the percentages are based upon the total row count. So we saw that we had 87% nulls, and now it's taking all that into effect. So when we take a look at this distribution of all this data, it bubbles it up. So, and I think we could see a nice kind of curve here, how at 25 it kind of peaks, and then everyone else kind of boils down at the end. All right. So there's a couple other tools that are in there. I'm not going to cover those right now, but it is an interesting tool, and again, free stuff. Right? Stuff that's already in the box. We already have it with Visual Studio. And if you don't, you could just download the Performance Business Intelligence pack for Visual Studio. It actually integrates with the shell. You should be good. And you could run this up against to whatever you like. All right. We talked about all that, functional dependency, value inclusion. There is one other tool that the last time I gave this presentation that someone had yelled at, what about Talend? And I'm like, I've never heard of Talend. What is that? So I decided to throw a slide into it. I haven't been able to get to work on this particular machine. Otherwise, I would have done a demo on it. But it is an open tool. It's a data profiling tool. It is open source. It is based on Eclipse. So if you're pro Eclipse, yay. If you're anti-Eclipse, boo. But it does do some interesting stuff. So it does all the data profiling stuff that we have, probably in a little better way than SSIS. It's worth a look if you're doing some of this stuff repeatedly. So that's Talend Open Studio. Kind of check it out. I thought it was interesting. Next time I do this, I'll actually have a demo on it, if I can get this running. Dang JDBC drivers, you just don't like me. All right. So as I start wrapping up here, I was doing this a lot. So I was going and taking a look at data, taking a look at systems, trying to look at the data and trying to get an understanding of that. And I was writing the same queries over and over again. I didn't know about the SSIS stuff. I didn't know about Talend. I kind of knew about Informatica. I saw the price, and I said, that's OK. I'll go ahead and write my own queries. But I started doing all this stuff over and over again. And I said, I want this in a better way. So I went ahead and wrote my own stored procedure, and that's called SP Data Profile. I've got one SP Data Profile user, you the man. Sitting in the corner over there. You know what's up. So one thing I really love to do is type everything out. So in SP Data Profile, I could just type SP Data Profile, give me a table name, and it will give me actually output for it. I don't have to go click in the columns. I don't have to do any of that stuff. It's all kind of right there. What it will give me is a table schema. It will give me null ratios and unique values. It will give me column statistics. It will give me a candidate key check. So if I give it a string of columns for a particular table, it will say, hey, these are the duplicate columns inside of here. It does the column value distribution where it gives us the counts. And I could actually view the indexes and foreign keys as well. So let me give you a quick demo of that because we have another 5 minutes. So might as well use those productively. And that's all right here. So first thing I'm going to do is I'm going to take a look at this SP Data Profiles for users. Ooh, that's a new feature I haven't seen. Let's reset that. And we have the same thing that we saw before as we ran against the DMV. So I've got the row count that's up here, and then I have all the columns underneath it, the length, the precision, and something that I've always found it important to take a look at is the correlation. Because sometimes someone says, oh, we have a case sensitive or insensitive database, but I need this column to be case insensitive. So when you write queries up against it, you're not thinking that this is a case sensitive column. And you start getting these weird issues as far as, hey, that came back this count, and this came back this other count. What in the world is going on here? And it seemed to be a casing issue in your where clause, in your predicate. So I've always find it nice to understand, hey, do I have any weird things going off? In this case, That's CI is your case insensitive, and that's what you would be triggering off against that. And that's just something that I threw in there because I've run across that multiple times. Another one is if I could run this up against with indexes. I look at indexes all day long. And there we go. There's all of our indexes here. So if you're a developer developing against queries and you don't really have a lot of control over your indexes, you could again say, just run this and say, OK, here are all my indexes. Is it clustered or non-clustered? Is it unique? Is it a primary key? And then what my index columns are and what my included columns are. That way I can actually create a query that's a little better, it's a little faster, and it's running up against the indexes. Now, if I have a little more control over the indexes, then I may be able to create one on my own. But this way I could create my query right up against those indexes that already exist because I know that they're there. All right, so foreign keys. We could actually see the foreign keys in here as well. And if you take a look at this, I'm not in Stack Overflow anymore. I've run against the InventureWorks database. So just from one command line, I don't have to go click the drop down to a different database, which is super annoying. But I could sit here and say, OK, here's my relationship. Here's my parent table. Here's my column. And here's what's referenced. So I could see all my relationships without going to the crazy designer, which is ridiculous and doesn't work very well. And I could see all the relationships kind of right here in my text window. So cool so far? Interesting? Not interesting? Silence is deafening. So we could do the same thing with overview of the foreign keys. But if I wanted a little more detail, I could run that. And so this, I've given it a switch of 1, and that this will give us a little bit more detail on my columns here. We get mainly the same information with our columns, but I get the number of unique values, I get my unique ratios, the number of nulls, number of null ratios. Now, if I went ahead and the zoom is killing me. If I take a look at my age, and I say, hey, I got number of unique values 82, number of null ratios. Come on, scroll. Thank you. Number of nulls, I would have seen right outside the bat that I have 87% nulls. It would just been really apparent to me that that is my null percentage. I wouldn't have to create another query to do that or anything of that. I should put the min length and max length in there just for the issues that we had talked about. Is something too long for me to stuff it somewhere else, right? I find that more important than, oh, look, here's my actual distribution of number strings in there, the counts of the columns. That doesn't make any sense. I've got the column statistics, and this is going to take just a second to run. I did give it a sample value of 10%, so it's only going to give us 10% of the actual table. It is 2.7 million rows. It's going to take a little while. Most of the time, I'll just run it at 100, but for demo purposes, we'll just run it at 10%. And this will give us min value, max value, median standard deviation, and this is our age right here, and the exact same values that we saw before, right? So there's no reason for me to open up Visual Studio, no reason for me to open up SSIS, do all the configuration, run it, and do all that stuff. It's all kind of right there. Now, if I want to do some benchline performance stuff and kind of keep all this, I could dump this to a table, or I could actually run SSIS and save the outputs in different values and things like that. But then it's in XML, and well, frankly, no one likes XML. I actually had one person say that they did like XML in there. And I was like, what am I supposed to say about that? I'm sorry? I don't know. And here we're doing a candidate key check against all these columns, display name, location, website URL, and creation date. And we actually have two rows that are duplicated here. So either I could delete one of these, or I have to figure out what to do with that. So here I'm doing an actual candidate key check, and it's all in there, and I don't have to write that. The other thing I put in there, a client had requested it, was the actual SQL. So if I go ahead and copy that and paste that into the query, SMS, it will actually give me all the detail of all that. And I don't have to rewrite all that querying for that. It all dumps it in there. So I've tried to make it easy for us to actually dig into data for future use. And of course, the final one is the column value distribution, and this all should look very familiar to us. And here we have the percentages and the things we missed, and obviously the weirdness that we had saw before. So this looks pretty interesting to everybody? Okay, so the deal with this is that originally I had it kind of locked up. You had to give me your email address and your name, and I was going to do a little bit of marketing around that. But since then, I've taken a full-time gig, and I was like, well, I don't need your email address anymore to market to you. I never felt really right doing that anyway. So last night I turned the switch on, and you could just hit a button and download it and go to my website for SP, or Google SP Data Profile. You click on it, and you're going to download it. It's there. I am seriously considering open sourcing this and putting it out there on GitHub. I'm actively working on it right now, so it's not tight as I want it to be for me to hit the publish button on that. So if you would like an open source version of this, talk to me afterwards. I'd love to hear your thoughts on that. I'm very close on that because statistics parser and data query generator, they're both open source fully, and I'm considering doing this for the same thing. So let me know your thoughts on that. And any questions we have no time for questions, but any other comments? You could get it here, SP Data Profile. Got that? Or just Google it. I Googled it last night, and that's how I found it. I Google my own site. That's how I do it. All right. So this is it. This is me. This is all I've got. You can follow me on Twitter. You can follow me on any of these other sites as well. Joris.net, the actual slides and everything, like I said before, it's all out there. If you have any questions, I'm available for you. I'll be here all week, all weekend. All right. Thanks, everybody.